I already spinned up a Foundry project and I created a file called arithmetic.so. So if you don't know how to spin up a Foundry project, I'm going to leave a link in the description on how to do that. So this contains just basically few functions, arithmetic that you could already guess. So I have addition, subtraction, multiplication, divide, modulus, exponential, and this two I'm going to talk about it later. So let's just go into it. So first and foremost, let me test my functions. So I'm going to get into this. So to test my function if it's working, I'm going to use forge test triple variables. Because everything works fine. So I'm going to spin up Solidity shell. So this is just a terminal that you can use and test out your Solidity functions. So I'm also going to leave a link in the description on how to get that. So Solidity shell. Okay, so it's up now. So I'm just going to basically test this function. So this is just an addition function. It takes two parameters, units A and B. So it returns an addition of both. So this public pure returns simply means that it's a public function. It's pure means it doesn't read data from the state, and its return simply means it returns a value. So you can see that they are the same modifiers for all of my functions. And so I'm just going to test out this function now. So define it in Solidity shell. So I'm just going to call it add. So I'm going to pass it into parameters 2, 4. So you're already expecting a 6. So our function works fine. The same thing with the subtraction. So I'm going to define it here. Then I'm going to do sub 5, 2. 3 works fine. We're going to do a multiplication of, any number that comes to mind, 3, 7, 20, okay, actually it's 4, 28. So divide. So this is so simple. Divide 4, 2. Already guessed modulus. So I'm going to be looking for the remainder. So mod 10, 4. Should be expecting a 2. What's it saying? Okay, let me just drag this up more. Saying declaration, blah, 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 blah. Wait, didn't I declare this function? Okay, let's do it again. Okay, I didn't declare it earlier. So mod 10, 4, that modulus, that's 10 divided by 4 will give you 2 remainder 2. So mod actually means the remainder, not actually the whole part of it. So exponential, so this is just like saying base raised to power another number. So I'm going to paste. So I'm just going to do exponential 2 to the power 3, expecting an 8. Okay, so you can see things actually works as expected. So but there is a little problem when it comes to working with float for Solidity. So actually used numbers that wouldn't give me the error because I'm getting to the error. So let's assume that I do something like sub 4, 5. There is a problem. This is because the value would give me -1, and Solidity doesn't support negative number, as we already said in our function for subtraction. We are saying that we're expecting units, 2 units, unit A and unit B, and unit simply means whole numbers. that means unsigned integers. So when I'm actually returning a whole number too. I'm actually returning a unit too. So when my return value becomes a negative number, there is a problem. So basically the whole function execution reverts. So just think of reverse as throwing an exception, although Solidity doesn't actually throw exception, but it just halts the execution of the function. So think of it as revert. So why exactly does this happen with Solidity? Because Solidity doesn't actually support floats. This is just because that Solidity, we use Solidity to write smart contracts, and when you come to the blockchain, tiny changes can actually cause the blockchain to split. So let me say when you try doing a calculation like 2 divided by 3, you could get something like 0.666 for some calculators, but for some other calculators you can get something like 0.6667. So this might actually seem very little, or while you're doing your normal calculation you can actually overlook it, but then when it comes to node agreeing on the blockchain, they actually need to have something deterministic, and decimal values are not always deterministic for all calculators. So this is actually why Solidity doesn't support floats. So when you're doing your calculation in Solidity and then you end up with numbers that are less than zero in decimal places, there's always a problem, right? So when you get numbers that are like 0 point something, there's a problem. Or when you get a number that if it's even 5 point something, most times Solidity truncates the decimal part. But if it is actually less than zero, then it's actually a total revert. So what happens when you have something like this? So this function here is actually saying, okay, I want you to permit me to do this, even though that I know that there might be errors coming from it. So that's when uncheck come into play, because uncheck simply means, okay, don't computate this particular line of code. Don't check it. Just leave it. I'm actually sure what I want you to give me. So okay, prior to Solidity 8.0, there's something called overflow and underflow. So this is when okay, for overflow, it simply means that you actually attained a value that is higher than the uint type that you specified. So when for me to have an overflow of uint 256, that means I actually got a value more than the maximum number of number that uint physics can contain. So uint physics by contains a maximum number. So how do we get the maximum number of that a particular uint type can contain? So for uint 256, so it can contain the maximum number of when you do 2 exponents the type, which is 256, minus 1. So this is when you process this calculation, and this is the maximum number of number that 256 can contain, right? So for uint 8, it's going to be uint 8 is going to be 2. It's going to be 2 exponent 8 minus 1. So for you in 16, 32 and thereabouts, so you just, what actually, this other parts remains the same for the calculation, but what changes for every type is this. So for you 16 here will be 16, for you 32 here will be 32 and thereabouts. So when we process this calculation now, so let me do this here. So this is the maximum number that you 256 can contain. For uint 8, this is the maximum number that it can contain. So 255. So in a case where we actually tried, okay, for me to actually demonstrate how an overflow can happen, I can use my addition. So in my addition function, I'm actually calling I'm actually passing two parameters and it will do the addition for me. So in this case, I'm going to call add, and I'm going to do 1 comma this number now. So automatically, I'm actually trying to attain a value that is 1 more than the maximum number that the range 256 can contain. So it's going to throw an exception for me. Okay, then copyright. So I'm going to copy this, and this is it. So you're saying that there's an exception, so it's a problem. So there's a revert. Let me be using revert actually, because that's what Solidity does. So there's a reversion here. So, but if I do the same thing for this uncheck add, you'll see that it's going to go through, because I'm actually saying, okay, permit me to do this, don't check this particular line of code, skip it. So so I'm going to define this function. What's the problem? Define this function, paste. Have I defined this function before? Okay, I think I've defined it for. Okay, so let me try calling it. So I'm just going to uncheck. I'm going to pass in 1 comma, where is that large number? So you're seeing that it gives me a 0. So this gets me to telling you why this is this way. So one thing with overflow and underflow is that when an overflow occurs, it actually gives you the minimum number that that particular unit type can contain. So the minimum number that a unit 256 can contain is 0, and the maximum number is this. So, and it's vice versa for overflow. So for underflow rather, for underflow, when it gives you a number lower than 0, it actually gives you the value that it will return to you will be the maximum number that unit type can contain. So for me to get an for me to demonstrate underflow now, so I'm just going to define this function. I don't know if I've done that before, but I'm just going to see if I've done that. Okay, I haven't. So now for me to demonstrate underflow, I'm going to try and perform a subtraction. So in this subtraction, I'm going to do a subtraction that would normally give me a negative number. So I'm going to do sub 5,6. Oh, this will give me an exception. So I'm actually going to call uncheck sub. Uncheck sub. Five comma 6. So you're seeing it now. So it's giving me the maximum number. So if you check this number with this number, they are the same. So that's one thing with overflow and underflow, because it just gives unexpected results. So just imagine I was expecting -1 and I'm getting a very large number like this. And in this other case, I was expecting this large number +1 and I was getting 0. So just imagine when you're doing a calculation, let me say you have a smart contract that calculates users balance, and then a user just withdrew, and then you want to subtract what they took away from their current balance, and then their balance is getting to like minus something, which is what you're expecting, but then you're getting this, which means you're going to be incrementing the user's balance by this. So is very undeterministic, and it actually brought a lot of bug in the previous version prior to 0.8. So that was why Solidity actually had to implement overflow and underflow check in their current versions, right? So if you're working with any Solidity version that is prior to 0.8, just know that there is no overflow and underflow check. And if the contract is not using libraries like safe math, then there is a problem. Unless that you're so sure of your contract, which you shouldn't just do that. So, but for uncheck, for using while using uncheck, you need to be very careful, and you need to be very sure that you know that this particular line of code will not overflow or underflow, or you're very sure of what you're doing, or if that's actually your desired result, then no problem. So while using this, make sure that you know why you're using it. Don't just use it because you just want to use it, right? So another reason why persons use uncheck for lines of code that they're very sure, or block of code that they're very sure that it won't underflow or overflow, is because it helps save gas to an extent. Because if you're doing a particular calculation and then you're sure that this won't overflow or underflow, then you're using uncheck, you're saving gas. Because what actually consumes gas is because gas are used for computations. So when you have complex calculations that normally you would use gas to compute that, by using uncheck, you're saving yourself the gas that will be used for computing that. So it's a way of saving gas. But as I said before you use this, make sure that you know why you're using it, and you're sure that is the desired results that you're expecting is very, very specific. So that's that for unchecked. So right now I've actually talked about overflow, underflow, unchecked. So another thing that I want to talk about is in the case of division. So it still revolves around Solidity not supporting floats. So when I did my division earlier, I actually used values that would work perfectly fine. So just like saying 6, comma 3. So this will give me 2. So what's if in the case where I have a value that would give me a fraction, or basically that would give me a decimal? And you know that I already said that Solidity doesn't support floats. So, okay, let me say for instance, I want to calculate calculate 10% of 200. So normally this would just be, this is still saying 200 multiplied by 0.1, right? So this is very right too. This is a very valid calculation, but in Solidity it's not valid. Why? Because I already defined my function. So let me say I'm going to be using my multiplication function, which I defined here. I actually said I need two unsigned integers, right? And 0.1 is not an integer, right? So it's not going to work. So how do you go about this in Solidity? So what you would do is that you would have to get a value that would make this a whole number, right? So this is still same as saying 200. It's same as saying 200 multiplied by 10 over, basically 1 over 10 rather, right? So by the time the fractional value of 0.1 is 1 over 10. So, and this actually makes sense to be saying that this is still equivalent to 200 divided by 10. So when working with percentages, you have to like get the percentage part of your arithmetic to a whole number, then you always divide, right? So this was supposed to be a multiplication, but now we've simplified it out to a division. So in this case now, for me to get 10% of 200, I'm going to rather be doing divide. I'm going to rather be using my division function. I'm going to pass 200 comma 10. So this would give me my desired result, which is 20, right? So another thing again is that, okay, what happens when we actually divide and get a value that is not a whole number? Is higher than 0, but it's not a whole number. So let me say when I want to do something like this, divide 200 by 11. So normally this wouldn't give me a whole number, we all know. So but then let's see what Solidity would make out of this. So divide 200. I'm going to give 200 comma 11. So you're seeing that it's giving me 18. Normally this is not supposed to give me 18, it's going to give me 18 point something, right? So but in Solidity, when you get a value that has decimal part, is going to truncate it. It's going to like throw away that decimal part. So but you know that when you're actually working with numbers and you need the decimal part, this is actually a problem, because most times you can get something like 18.9. 0.9 is almost like 1, so it's something, right? So you have to like know how to work around that. So that's for this video, and thanks for watching, and thanks if you actually made it to this point. Thank you very much, and hope to see you in my next video. Thank you.